We're gonna take our time, slow down and design. Yeah.
Our story begins with the 8th International Permaculture Convergence in May of 2007 in Sao Paulo, followed by the convergence at the Ecocentro and the Amazon tours. Some people here will be familiar with some of this material that I'm about to present because I've given it now at a couple of convergences in the Australasian convergence and around the world. So, but I need to cover some of the science first in order to help people who may not have any background in this. My first exposure to the dark earths of the Amazon started with that permaculture convergence, and for me it began a fascination that continues to the present. This is an area of the dark earths in the Amazon known as Asituba. It's a historical dig, an archaeological dig. And today they are still using the same soils that have been continuously used for 400 years. They don't need fertilizer. The soils themselves work like fertilizer. The mystery which persisted in geological science for 400 years was how this happened, how this could be. And it has been a number of scientists over the years, but the discoverer of the secret ingredient was this man, Wim Sombroek. And he was a Dutch scientist working for the UN, and he was studying these soils, and he started coming across pieces of charcoal in the soil, and he was reminded of the Hongerwinter of 1946 when he was a little boy in Holland, and there was no food. And his parents would go out to the garden and try to grow food, and they would take the cinders from their stove and take it to the garden. And he remembered that, and so as he's going through these soils and these profiles, he's seeing these little pieces of charcoal, and he's starting to put it together. And he begins to do these tests and discovers these soils are very old, and in fact, the Terra Preta soils of the Amazon are man-made. So he discovered the secret. The secret is what we are today calling biochar. And the distinction between biochar and charcoal is simply that biochar is something that you would want to put in your garden. Charcoal might come from any number of sources. It might be okay for a barbecue, but it might not be good to put into your garden. You have to understand that there's of the carbon on the land, 75% is soil organic carbon, which cycles through living things. Very little of this was in the Earth's atmosphere until recently. Carbon's capacity to absorb energy causes the air to heat up in the upper atmosphere, and working as a greenhouse gas, it also allows long-wave solar energy to pass to Earth, but it traps the shorter wave reflected heat, which warms the lower atmosphere and passes some of that warmth to the ocean and the land. The era of fossil fuels, beginning with coal mining and continuing today with fracked gas, has added gigatons of carbon to the atmosphere, which has destabilized the heat cycle of the planet. This is not a matter of scientific dispute, as we heard yesterday. The science is well settled. In soil, from 1 to 5% of biochar will oxidize in the first 10 years, but after that, the rest is virtually permanent, remaining unchanged for thousands of years. And the reason that it does well as a soil amendment, why it helps gardeners, is that it has this porous structure that forms. This is the cellular structure of the plant. But then when it's heated in the absence of oxygen, the gases expand and they pit the walls. So you see pores, and you see pores on the pores of the pores, and pores on the walls of those pores, yeah? So it's fractal, it's all turtles all the way down, yeah? And so as we look at these different minerals or different grasses or different kinds of things that you can char, they all have this capacity, which is a very large surface area. An area of 1 gram, about the size of a pencil eraser, is about the surface area of half of this room, yeah? 1,000 cubic meters or square meters. And so that enormous surface area is habitat. It's habitat for the soil biology. And it has also sort of a magnetic quality in that it draws nutrients and holds them. Like a coral reef, it has this capacity to hold life, to hold moisture, to release nutrients on demand to the creatures that live nearby. So we see this dramatic effect in soil. We see if you put it into maize, for instance, you get very dramatic yields. It can replace chemical fertilizers. And you know, the nitrogen and phosphorus cycles are also seriously out of balance. A recent study tells us that biochar amendment at 1 ton per hectare suppresses soil carbon dioxide emissions by 33%, but it also suppresses other greenhouse gas emissions, nitrous oxides and methane and so forth, by 37%. It actually retains nitrogen, it retains phosphorus, it tends to scavenge things that are present, too much of that in the soil, and hold it for slow release on demand by the nematodes and the other microorganisms that serve the roots of the plants. And so you see this dramatic growth of the root zone in the plant anytime you have charcoal present as a supplement. This is not new, actually. We've known that putting charcoal in your garden is good for your plants for a very long time, since at least the Nogyo Zensho, which was an agricultural encyclopedia written in 1697 during Japan's Edo period by a wandering samurai turned Zen monk, Yasuda Miyazaki. What we have not known until more recently was how that works. And it's curious that there was a debate in the late 19th century between Louis Pasteur and Justus von Liebig. There were believers in what they called vitalism that thought that soil contained organic life force. And Liebig contended that it was all just chemistry and physics. Pasteur said, in not so many words, it's the biology, stupid. And Liebig studied this and tried growing plants without any biological interference and discovered that the plants died. And he conceded that Pasteur was right. And he eventually studied biochar for much of his life and had himself buried in a coffin filled with biochar. Okay, now you are the brain of Gaia, and you have 4 organs that you're balancing for carbon and nitrogen, phosphorus, potassium, and other elements too. You have to keep them all in balance, but let's start with carbon. At present, there's too much carbon dioxide in the air, and reducing its concentration from 390 parts per million to 350 means we've got to take 300 billion tons out of the atmosphere. We can't put that into the oceans, and in fact, 350 is probably too much. So we need to remove between 900 and 1,000 gigatons of carbon dioxide from the atmosphere and lock it safely away. Land plants hold 600 billion tons of carbon at present, but Earth's soil holds 3 times that much. So that's the storage medium that we need. Fossil fuels are about 6.4 gigatons of carbon that we add to the atmosphere every year. Why? Because actually we actually add a lot more than that, but the oceans are able to take out quite a bit, and mineralization and other factors. While we need to rebalance the sources that we contribute to the environment, from cement and coal and other population demands, we also need to go back to net minus for a while to take the pressure off. So we need to find an amount of maybe 8 to 10 gigatons to lock up annually. After a century, that would bring us to 350 or lower and also repair ocean acidity. Does it work? Well, researchers have uncovered the evidence from the Amazon that the contact with the Columbian encounter, you had urban societies based around agriculture and forest management and aquaculture, and the rapid depopulation led to a large-scale abandonment and subsequent reforestation of agricultural lands. Analyzing charcoal found in soils and lake sediments and sites across the Americas, scientists have concluded that this forest regeneration sequestered enough carbon to trigger global cooling. We had another example provided in the Mongolian invasion of Europe. So Genghis Khan divided the Mongol Empire amongst his 4 sons. They conquered most of Eastern Europe from the Urals to Vienna. And they also extended the empire up through east through Siberia. Well, they were not nice people. They exterminated most of the populations that they conquered. And the regrowth of forests during the Mongol invasion absorbed 700 million tons of carbon from the atmosphere. I was interested to hear yesterday about the 1300 AD event and the sea level drop in the Pacific cooling. This corresponds precisely to the Mongol invasion. These are our best options. You know, we have these wedges, and we can get to, we can get our 8 or 10 gigatons of carbon from these wedges working together in coordinated ways. A good example of how this can be done, how we get there, it comes from Naomi Klein's book, The Shock Doctrine. Instead of disaster capitalism here, we're looking at preventive permaculture. After the earthquake in Haiti, we had Nathaniel Mulcahy at World Stove going to Haiti and setting up biochar producing stoves in refugee camps in the Port-au-Prince area. And then they went to the setting up community kitchens that were carbon negative, and then making micro-enterprise hubs to get people out of the camps and earning a living making stoves. In the tropics and actually around the world, 1 million children each year die of inhaled black soot. They die of pneumonia from inhaling black soot from 3 stone fires on clay floors in very modest buildings. So making smokeless stoves that make biochar and use 1/3 less fuel because they're pyrolytic is a solution to that. These stoves are made from earthquake rubble. And then he went on to the micro-enterprise hubs that he created, the possibility of not only making more stoves, but making the fuel for the stoves. So you can pelletize grasses and chips and waste materials, rubble from the earthquake that's burnable biomass that would otherwise become carbon dioxide or methane in the atmosphere, can then be turned into fuel for these stoves. And then he can look at the process by which these are measured, and what is the measured amount that actually remains in the soil after a period of time. How successful are the plants that are planted in this material, and so forth. Well, one of the things that he discovered, of course, is that Haiti is a charcoal culture. This is the cuisine of Haiti, is burning on charcoal stoves. And so how do you then keep the charcoal from re-entering that market and going into the atmosphere eventually anyway? What he did was quite ingenious. He started working with a non-governmental organization that was making composting toilets, and gave the biochar to insisted that anyone who received a stove has to give the biochar to the compost toilet. So this reduces the smells and also helps to dry the toilet. Then from there, the groups that were making the compost toilets would take the humanure and pass it to people who are reforesting Haiti. On a larger scale, we can look at this idea of preventive permaculture. The Biochar engineering company of Golden, Colorado is selling this module. It's a mobile unit that makes 1 ton per hour. It costs about $100,000, so very few people could afford such a thing, but they sell it to governments, like the government of North Carolina, which put it into use in the areas where the trees had died from pine bark beetle infestations. And so they had all of this potential for forest fire from the destruction of the forest. Instead, they went in ahead of time and charred those downed trees and put the biochar then into the new forest, so that the new forest is more drought resistant, more fertile, and more resistant to future beetle infestations. In a world where so many people cook on three-stone fires, you have to wonder, can they actually afford to make a metal stove or to buy a metal stove? And so my friend Doricel Torres went to Kenya. She was a graduate student in Cornell, and she started designing biochar stoves made of clay there in Kenya. So this is a simple clay gasifier. It's 1/3 more efficient than a rocket stove. It's smokeless, it leaves no ash, and it only just makes biochar. Anyone can make one, and no money is required. After the first year, you can immediately see the results. It doubled the garden yield in the first year. So in making biochar suitable for the garden, David Yarrow has given us the rule of the 4 M's. The product needs to be washed to cleanse it of tar and residues that make it hydrophobic and provide a little moisture to the microbial community. Straight out of the kiln, it's bone dry. And it has a huge adsorption capacity, and thus it is optimized for gardens by adding some minerals and the major cations, calcium, magnesium, potash, and also the anions, the nitrogen, potassium, sulfur. Encouraging colonization by aerobic bacteria and fungi can be sped up by injecting existing communities of beneficials, or simply by blending the biochar with compost. The optimal particle size is a nice grain size down to dust, the size that an earthworm could digest. So here Nicole Foss demonstrates the BC Machina Molino at the Maya Mountain Research Farm in Belize during our permaculture course there last March. This is the idea of an easy way to grind the biochar down without getting black lung in the process, and getting it down to the garden size. The biggest wedge we have is reforestation and agroforestry. It's one way to do this without diminishing the food supply using agroforestry techniques, but carbon sequestration begins to diminish annually as a forest matures. The juvenile trees simply sequester more carbon as they grow annually than do the older ones. We can optimize the sequestration capacity of forests by selective halving of the population, tree culling, at intervals of 6, 9, 12, 16, and 24 years. Nursery trees can be used for various things before being made into biochar. We can then either return the forest to a clear cut, a milpa-style cycle, or we can slow age the top grade timber, but that does not maximize the carbon sequestration. Now this is just a schematic. I would want no one to ever plant a forest that looks like that. But it's necessary in forest management to be cautious and proceed with the same holistic management practices that you would apply to drylands pasture recovery. You are managing for ecological service capacity improvement. So we want to look at the stocking of all parts of the system and try to redress imbalances that we see. We're trying to achieve mixed age, mixed species, animal biodiversity, multiple uses of the forest, and then finally healthy and resilient ecosystems. And we've shown through projects like the Alfred Forest and the Pioneer Forest that management for these goals actually produces more financial yield than the alternative, less sustainable, current industrial pulp, paper, and timber harvesting models, even before you factor in fossil fuel. Okay, so I've given you the science. That was the important piece I needed to download. Now I want to actually talk about some of the ways that permaculture is using this in the context of eco-villages, yeah? So you now have the tools to reverse climate change. It's time to move to the process by which we can bring that reversal into being. And we can begin by getting rid of the politics of combat negotiations, where you have two opposing viewpoints and each tries to gain an advantage over the other. And instead, let us proceed from those things on which we agree. All people in all cultures have essentially the same set of values. In eco-villages, we received a useful definition in 1991 by Robert and Diane Gilman, which says a fully featured human settlement with independent sources of initiative in which human activities are integrated into the natural environment in a way that is sustainable into the indefinite future. There are many pieces of that we need to unpack a little bit. One of the ones that I find is the most tricky is the indefinite future part, because we really don't know how the future will unfold over the next few years or few decades or the coming century. But we can look at all of the different alternative movements that came from the 1960s to the present. And eco-villages are not really trying to do anything new. They're rather integrating into a holistic interaction all of these different alternative movements, taking it to the village scale. And as they do that, we can now begin, after 20 or 30 years of this, to look back at some of these case studies and see what might be possible. So just in the context of reforestation of different areas and using agroforestry in your food systems, we begin to see in places like urban environments, East Lake Commons, and places in Atlanta where it's heavily industrialized and urbanized, as much as a 20% capture of farmland and a 10% rewilding. We take that out to suburbia, and we have models of eco-village development like Crystal Waters or Findhorn, which are fairly well-designed traditional developments, but with permaculture put in. And we begin to see 60% or so of farmland and 10% rewilding. We take it out to the rural areas like my home at the farm in Tennessee, or the Sassardi Reserve in Colombia, where eco-villagers take it upon themselves to add additional land solely for the purpose of creating more Zone 5, right? We want to acquire additional land. So the farm went from originally 750 acres to more than 5,000 acres under management today, managed as conservation reserve, zoned for human exclusion. And these areas can be 95% wild. This is the oldest continuously functioning eco-village in the world, now 83 years old. It's Solheimur in Iceland. It was started by Cecilia Sigmund's daughter in 1930 as a home and school for developmentally challenged children. And it had the benefit of a hot spring on the farm property that produced 30 liters per minute at 95 degrees. Today, Solheimur is working to reforest Iceland, planting millions of seedlings in their geothermal nursery. So they are transplanting these trees out every year, restoring their island nation that had been denuded of trees by Europe in the 16th through 19th centuries. And they're rebuilding the resiliency of that island in a time of climate change. If you think climate change is strong in the tropics, you should see it at high latitudes. And certainly Greenland and Iceland are experiencing it. Torre Superiore is a European example of rehabilitation of an 8th century village that was a ruin on a mountainous border between France and Italy, not far from Ventimiglia. And eco-village's best practice would be not to take away from farmland or wildland, but instead to green up brownfields and to rewild suburbia. Here's another best practice, which is designing for enchantment, which is how we win hearts and minds. Finhorn has been planting trees to reforest the Scottish Highlands that were deforested after the clearances. They enlist volunteers each spring and fall to trek the wildest parts of Caledonia and reinstate the missing bits of upland ecology. In China, we did a first eco-village design education training program in Guizhou province in August and September of 2010 with 29 participants. We've now later followed up with additional programs, and the Tengtuo is the China's model eco-village. It has the potential to become the first carbon-negative farming region in Asia by using their coconut husk wastes to make biochar. So less immediately obvious, but arguably even more significant, is the contribution of eco-villages to a radical transformation of values and consciousness. These are areas that we are close to the surrounding populations. We interact with surrounding populations, but we know and we reflect in our way of life that growth and well-being are not the same thing. And you can have well-being, you can grow your well-being, but you don't have to grow your consumption of material goods. We are reconnecting people with the places they live, so we are very integrated to the bioregional movement. We affirm indigenous patterns and practices. We are supportive of indigenous peoples. And we offer a holistic and experimental vessel for social experiments, education methodologies, transition paths. One of the best examples is the Sarvodia network of some 18,000 eco-villages in Sri Lanka that now has more than 1 million people living in eco-village. It is a pay-it-forward system where once an individual village achieves the basic human needs for its people, it has an obligation then to go out and adopt a lower quality village and bring that village up to the same level of living standards. It's a system where a village has a sister village, and then that village gets a sister village. And in this way, they have 18,000 villages, and they expect many more in the future. What we are attempting with permaculture and carbon farming and eco-villages is to reverse the degradation of the quality of life that's the inevitable consequence of population expansion hitting the limits of growth. We are trying to claw our way back up Maslow's hierarchy of needs and to push to the summit and to hold that high ground. The world financial system, industrial processes of degradation, soil depletion, and climate change are all pushing us in the opposite direction. We are the force that is pushing back to the summit. The farm is a cattle ranch dogleg in the middle of a remnant mixed mesophytic boreal forest. I'll wait for the translator. It looks like a golf course, doesn't it? And that's kind of funny because one of the things we have added in the past 5 years is an 18-hole championship tournament disc golf course, frisbee golf. But if you look at us from space, the fabric around us is wearing thin as the population continues to cut into and haul away the forests to make suburbs and strip malls. And so we are this sort of green area that has to be held and expanded whenever we can. The keyline management method is the fastest way we have to restore degraded soils. It doesn't release carbon to the atmosphere like normal plowing does. And we've been augmenting the technique with the advice of Darren Doherty, Elaine Ingham, Dan Kittredge, and others using compost tea, biochar in slurry, and remineralization. And here's a little bit more of that. I'm not getting audio. Don't have audio. I'm not getting it. Let me try this. I'll take it back here. I'll take it back a step. It's okay. I unplugged it so I can use the microphone because I plugged it in and I got nothing. So it's all right. I'll use the microphone. We can do this.
So what we start with is basically just water. You bubble it for 24 hours to get all the chlorine out of it. And then you add micromate from Mesa Verde, which is basically humate and fulvic acids to help lock up the leftover chlorine, drop it to the bottom, and then you're ready to fill your bag and put it in the water. And your bag consists of different types of soils, worm castings, bat guano. Those are the types of ingredients you want to add to the bag. Within the 24 hours of brewing process, you want at least a third of that bag to exit into the water. And then you're going to add fish hydrolysate as your micro meal, and that's going to get the fungi and the bacteria all fed and active and ready to go. And then I also sometimes add kelp. That's, depending on your application, kelp is a good one. Feather meal if you have that available.
Feather meal, what's that, broken up feathers? I mean, ground up feathers from poultry?
I actually don't use feather meal yet. I stick with kelp, micromate, and fish hydrolysate. Those are my main ingredients. But I also use worm castings in almost every batch I do, and I use bat guano.
Have you ever used biochar?
I have used biochar. I've used your biochar. I've definitely, I'm working on getting more into biochar. But the first year we did biochar, we didn't grind it up enough and we blew pumps. So this year we're getting it a little bit better down. And
so you soak it in the tea bag.
Soak it in the tea bag.
And that way only the fine stuff gets into the
Exactly, and then you can use that tea bag to put wherever, re-inoculate compost piles, re-inoculate anything, it'll help break it down. You can go bury that biochar around your yard and that'll get the longevity of the biochar rather than just spreading it straight on the ground. You'll get many, many more years out of it. But the slurry type biochar is also very, very effective. That's what I'm trying to get into, is ground up slurry actions.
So another use for compost tea. So using these methods, you can add a meter of topsoil in 3 to 10 years, and that's not just drought and flood proofing, but also rebuilding the soil carbon reservoir. And we have also been learning from Eric Tonsmeyer and David Jackie and others and taking these lessons into our land management, and we offer opportunities for people to come and learn these things at the farm, and we invite other teachers to use our venue for teaching, and we send our teachers and graduates out around the world. The next agriculture may not be about chemistry, it will be about biology. We're just beginning to learn about the quantum entanglement of all life forms into a non-linear web of mutual support. And every time we use an antibacterial soap or discard something made of plastic, we are destroying that web. When we speak of Columbus causing the Little Ice Age or Genghis Khan causing the internecine conflicts in Hawaii, we are talking about quantum entanglement of humans and Gaian systems that we don't remotely begin to comprehend. The genius of sequestering carbon in compost with biochar is that it provides habitat and sanctuary for microbial life. It's more than just a sponge, it is a soil coral reef. We are putting out a call to the first aid station in nature and asking them to send an ambulance. So this is a DNA spectrum of how quickly the diversity of soil microbes goes up if you add biochar. It just explodes. And we know in recent years we've been learning more about how human nutrition processes work, and bacterial cells are much smaller than human cells, and there are at least 10 times as many bacteria as human cells in the body, approximately 10 to the 14th versus 10 to the 13th human cells. There are 205 identified genera that exist in our body. And the mass of microorganisms is estimated to account for 1 to 3% of total body mass. Bacteria create the next generation by epigenetics. They switch genes. They can turn things on and off. They can decide what's needed next and become that. And if we have a smorgasbord of genetic material available for them to choose from, they can recode with each generation. So by making available genes in greater quantity and biodiversity, bacteria choose, and this is how Gaia evolves. This is how Gaia heals. So as you look at the human nutrition cycle, we see that it goes everywhere from the bacteria that we find in the plants and how they grow and how they access food to humans and how we process food and store food and make our foods, you know, like bread and chocolate and coffee and all of these fermented products that all involve bacteria. And then how we use those in our gut to digest our food and how healthy we are as a function of how healthy our gut flora is. And then as we move the humanures back around to the top end of the cycle with compost, the vitality of the compost pile matters a lot. And that's what creates the conditions for future plant growth. So we're beginning to experiment with other ways to increase the biochar in our environment. Hans-Peter Schmidt in Switzerland began experimenting with clay plasters that are 50% biochar, 30% sand, and 20% clay. The biochar is ground to less than 5 millimeter particle size, and it results in this anthracite-colored plaster with a very noble, slightly shimmering appearance, but it can be covered in lighter Alice coats. It reduces not only mold, but electromagnetic radiation. So imagine the soil reef there, and it's drawing the mold spores from the air. It's drawing fungi and yeasts and viruses out of the air. This is clean building tech. It's biobiology, yeah? So it makes sick buildings healthy. And you can use any biomass in a building. It stretches the carbon cycle from 12 years to 100 plus years. So this is a straw building, straw infill building at Tennessee, the Eco Village Training Center. And now we're getting ready to plaster it with biochar. So we have a slip-form clay straw in the wall, we have timber framing, and we also have the biochar in the wall. All of that is long-term carbon sequestration and healthy mold proofing in a wet climate. And you can think about that also, by the way, in a climate like this where you have a lot of cinder block, and you can begin to plaster the walls with biochar, and it's going to change the humidity. It's going to make it feel cooler inside, as well as making it healthier and avoiding mold. Incidentally, we're also blowing glass for the stained glass windows in that building by melting old wine bottles in these biochar stove camps that we've been having. So we make bamboo biochar, and in the early stage we get the fire up really hot, 1,000 degrees or more, and we can melt old wine bottles for stained glass windows. Biochar serves as a helpful media in establishing living roofs and also in gardens and orchards. And this is the home of Graham Strouts in Ireland, and that's Rob Hopkins in the foreground. Winter heating and cooking can supply enough biochar to provide for the gardens and natural plasters and food supplements, various different kinds of supplements. This is how we can come to inhabit the earth in the Anthropocene. This is Earth Haven. It's earth sheltered. Earth Haven is a good example of how you can sequester. They sequester more than a third of their entire footprint from all their businesses, all their residences, and all their visitors, and their visitors travel there just by having a lot of forests that they manage. And so eco-villages can become guardians de la tierra. We are the midwives of the next forests. Here at Sassardí in Colombia, they protect and manage a 10,000 hectare national forest, a national park that they help create in the Darien Peninsula. And this is like one of the treasures of biodiversity on the planet, more than 400 varieties of frogs there. Yeah? So it's very important to preserve these places. How do we speed up the process of adoption? Well, my thinking is that if you can get Japanese school children to adopt it, you can make any meme viral. So we need to have ways to make viral memes, yeah? You can go onto the internet and you could get from China bamboo biochar products, wearables that become soil amendments when they're worn out and composted. And in fact, the military and the police are making sniper gully suits and Kevlar body armor because the biochar woven material absorbs heat signature of the wearer. But one of the things I recently saw at a biochar conference was these bamboo encrusted peanuts. So this is bamboo biochar as a crunchy outer covering on peanuts made in Taiwan. The MIT is not that it was some futuristic bamboo charcoal technology from a research institute in Boston. It was actually made in Taiwan. But the peanut crust is 5-year-old bamboo burned at 800 degrees Celsius. And there is also a Japanese anime TV show that's called Yakataki Japan, which is about a kid's quest to create a national bread for Japan. And the 29th episode, which you can download if you have time and bandwidth, is about bamboo biochar bread. An evil bakery rips off the diet bread recipe of the good guys, who then counter with bamboo biochar bread. But spoiler alert, the bad guys are left in tears at its flavorful beauty. Somewhere in there, they also manage a giant robot battle. But I found charcoal in Japanese desserts, real-life charcoal bread, and a restaurant in Vancouver that has bamboo charcoal ramen. Good for your digestion. And I'll speak more about these additional yields in my talk at the Convergence, but to suffice it to say that we're really limited only by our imagination, as Jose Marti said. And we should be thinking about how you can sequence the uses of bamboo so it can start as a water purification filtration system. It can proceed to silage for storing haze over winter, helping the fermentation process in the silage, and then it's eaten by the cows, and the cows have a better digestive process. They don't need antibiotics and so forth. And then when that becomes manure, it goes into the floor of the barn, and that becomes a much nicer smelling barn. In fact, it's being used as a litter amendment for poultry now, and also for pigs. And then it goes from there, of course, into the compost and becomes a soil amendment. And I also found it very helpful to see uses like electricity. So I think the fire code here prevents me from actually doing this, but this is a little stove that's a camp stove that's made by BioLite, BioLiteStove.com, and it heats up your evening meal, and then while it's working, it has a little thermocouple inside that charges a battery in this orange case. And so the orange case has a little fan, and as the battery charges, it goes from yellow to green, and when it reaches green, you can flip this down and you have a USB port, so you can charge your smartphone or your iPad there. This was very helpful after Hurricane Sandy. They put these out all over Brooklyn and Flatbush and the areas around the Jersey Shore to help people have smartphone or cell phone use during the disaster. So these things are becoming more popular and coming into different models. These are the models that BioLite is testing right now in Africa. You can actually get a whole household or business size model from a factory in Berkeley that comes on a shipping pallet, can go anywhere. In Japan, they actually started a movement of cool food. 40% of Japan's land area is Satayama. And in Japan, it's called secondary nature, meaning that man-made wilderness managed by continuous low-level disturbance as a cultivated ecology. It's rich in biodiversity, in ecological services, but in recent years it's suffered from the demographic shift. There are no young farmers left to manage it. Invasive species have come in, feral pigs and thick bamboo groves. They rage through the rice paddies. So the Hozu Farming Co-op in 2005 started with 338 of the 352 farming households in that region. And they have only 150 hectares, 370 acres, and that's 97% of the farmland. So you can see that most Japanese farms are under 1 acre on average. And this project was started as a partnership between the co-op, the local university, and the local government, which they called the Carbon Minus Project. The idea was to harvest bamboo and deadwood from the Satayama lands, make biochar, and use the biochar to grow vegetables and to brand the produce cool foods in stores. So they could take cabbages that they grew in biochar and brand that as cool slaw. And they would sell that to families, and they would find that they was very popular because families were concerned about the future and about what it's going to be for their children. So they started marketing these with cartoons and books that they would give to schools to tell about Mr. Biochar and how he works in the soil and how he helps make the plants more nutritious and how they don't need fertilizer anymore and all these good things. And it became really a business model that's now expanding. They sequester 154,000 tons of carbon dioxide annually. That's a third of the entire region's footprint. At $40 a ton, the co-op could be earning $6.2 million from carbon credits. So the whole idea there was to make the idea not carbon negative, not carbon minus. This is bad neurolinguistic programming. We need cool. We need to find out what's going to attract Japanese school children. So it's got to be cool food, right? Maybe an app for that. And so a similar potential exists wherever cacao is grown. Craig Sams is trying to do it on a large scale with his chocolate bars in the Toledo Cacao Growers Co-op. Chris Nesbitt and I have been teaching this in our course in Belize, in the Permaculture Design course there every year. And Chris has now got local villages, Mayan villagers, who are making these stoves out of old acetylene tanks and things, and oil drums. And Chris makes his feed for his hogs. He boils breadfruit on his stove, and then has the biochar, which goes into the cacao. And you can imagine seeing in the store someday, not too distant future, charcolet from Belize. Yeah? But maybe also with the crunch of charred bamboo peanuts. So a Hawaiian mahogany farm, the nurse trees are thinned to release the mahogany and other overstory, and then chipped or sawed into lumber. The chips are made into biochar and electricity. The heat is used to cure the lumber and also to run an ice plant that supplies the local fishing fleet. The fertilizer and the mulch are used to improve community gardens and forage pastures. And the design team is also available to consult or travel anywhere. This is on a largest CSA in Europe. It serves about 20,000 subscribers. This is Thomas Hartung's farm in Denmark. And he has diversified out to making these biochar amendments in his greenhouse that heats his greenhouse for the winter. The gases are tapped and used. The electricity is produced by a Stirling engine. And then he's now selling these systems all over that part of Northern Europe. The Warsaw Conference just ended in grief and tears, but it's possible to proceed without United Nations support or carbon taxes or incentive programs. We can find the benefits without that, although having that would speed up the conversion of modern agriculture and habitat design enormously. This is a method that was developed by a group in Ireland, which is that you would have remote sensing, where you could actually see from space which nations are actually beginning to add carbon to their soils, and you can determine this from the carbon content in the foliage and the leaves of the trees. And you can actually begin to say some nations are depleting their carbon every year, and some nations are improving their carbon stores every year. And so you tax those who are depleting, and you reward those who are improving. And in this way, you create a virtuous cycle, and everybody gets envious, and everybody starts to do it. So some current programs of the Global Eco-Village Network. We have this program called Sites, which is a project of Jen to aggregate websites, create fora, and cross-fertilize between all of our different projects. The Solutions Library is a searchable database of innovative approaches to categories of problems. We Create is a fab lab with digital printers. It's being assembled at the Cloghjordan Eco Village in Ireland, which is intended not merely to help construct their eco village, but to help transition the surrounding parts of County Tipperary. And then the Baltic Sea Initiative, the Baltic Sea Program, this was a project funded by 1.5 million euros from the European Commission 2007 to 2013. Also additional contributions raised by the 9 partners. And the objective was to create guidelines for regional development, new village-based technologies similar to We Create, and recommendations to governments for speeding the process and ensuring the success of new eco-villages. This could go entirely cool in a second stage. Education, particularly of youth, is an important part of our strategy for accelerating change. Since 2006, Gaia Education and Gaia University have delivered more than 200 programs in 33 countries over 6 continents, graduating more than 4,000 students. You can download our Eco-Village design curricula and our books, The 4 Keys to Sustainability set, for free at GaiaEducation.net. It's in English, Spanish, and Portuguese. So there's a saying in Ireland, or maybe Jose Marte said this too, gathered by each other is how the people live. We need to reach back from the secure places. You know, we are not islands in Eco-Village. We need to pull up our brothers and sisters in Haiti and Somalia and Zimbabwe and Burma and Timor. That's the only real security that's possible. Not whack-a-mole with drones and Hellfire missiles to maintain some failing empire. Eco-villages are a one-world psychographic, the transitional vessel for the consciousness shift from me to we. There is no away. That's just basic ecology. It is one planet, a blue island in space. There are no lifeboats. We can no longer be me first. We first. So thank you very much.
Slow down and design.